Hello everyone, this is Prashanth. I am continuing the last session of IOT. So in the last session we discussed about IoT enabling technologies. Basically we have different types of IoT enabling technology, that is wireless sensor network, cloud computing, big data analytics, communication protocols and embedded system. So in the last session we discussed about all the IoT enabling technologies along with real-time examples, use cases, requirements and advantages, disadvantages of all IoT enabling technologies we discussed in the last one. So now I'm going to enter into the another new topic, that is IoT levels and deployment models. So basically as per our information technology, we have different 6 levels of IoT levels. So level 1, level 2, level 3, level 4, level 5, level 6. So what is the specifications of levels from 1 to 6? So for example here, so in the first level, every level having some specifications in order to use in the IoT devices. So along with that we have some disadvantages also. So in order to overcome the disadvantage, we move another level, that is level 2. So like that, level 2, level 3, level 4, level 5, level 6, like that we move from level 1 to level 2. IoT level 1, level 2, level 3, level 4, level 5, level 6. Next, deployment templates. What are the deployment templates? We will see in the further. So these are the some based on the number of monitoring nodes, based on the monitoring nodes used, types of database used, complexity, simplicity of analysis, computation. There are 6 levels of IoT. Different applications are implemented based on this level. So every level having some specific applications in order to use in the IoT devices we use. Okay, based on the monitoring nodes, types of database used, complexity analysis, computation. So based on these 4 factors, the levels are divided into 6 categories: level 1, level 2, level 3, level 4, 5 and 6. So every level having different specifications, different application. So the IoT system consists of these following components. So every level having these common components, having a device, resources. What are the devices? Either it may be sensors, actuators or any drivers. Next, resources. What are the resources? Having either for communication purpose or non-communication purpose, whatever it may be, it having some specific resources to develop. Next, control services, databases. In order to store the data, we have some database. Next, web services, analysis component and what is the application of particular level, either level 1, 2 or 3, like that up to 6. So these are the basic components having every level of IoT consisting: device, resources, control service, database, web service, analysis component and application. Let's first start with the elaboration of these words. Device. The IoT device allows, what is the function of device? It can be used to identification, whether it is communication or non-communication or network like that. Identification, remote sensing, actuating and remote monitoring capabilities. The basic functions of device: identification, remote sensing, actuating, remote monitoring capabilities. Next one, what are the resources? Resources are the software components on the IoT device for accessing, processing and storing sensor information or controlling actuators connected to the device. Resources include the software components that can enable network access for the device. So this is about what are the resources. Next, control device. Controller device. Control service is a native service that runs on the device and interact with the web services. The controller services sends the data from the device to the web service and receive commands from the application for controlling the web services. For example, ESP 8266 programming set of application programmable keys and SSID like that. So this is device, resource and control services. Next, remaining three, database. The database can be either local or in the cloud, store the data generated by the IoT devices. Next, web services. Which type of web services it can provide for us? This act as an interface between the IoT device, application, database and analysis components. Web services can be implemented using HTTP, REST representational state transfer principle or WebSocket using WebSocket protocol. So we have some communication models. We already know we have different types of communication models. REST based public subscribe communication model, request response communication model, push pull communication model, like that we have different types of communication models also. Next, along with that, communication APIs is also. Communication APIs. In the communication APIs, REST based communication APIs and WebSocket communication APIs. So this is WebSocket communication and REST based communication API in the web services. Next, the last one, analysis component. The analysis component is responsible for analyzing the IoT data and generate results from which are easy for the user to understand. Analysis can be performed either locally or in the cloud. Next, application. IoT applications are an interface that user can use to control and monitor various aspects of the IoT system. So these are the some components of IoT levels: device, resources, control service, database, web services, analysis component and application. So these are the elaboration of these words. What is device? What are the resources it having? What is the control services? Next, databases. How much of database it can be stored? Web services, either maybe by using communication protocols or communication models or communication APIs. And analysis component to analyze the stored data along with the applications. So let's move on to the first level of IoT, that is level 1. So this is the black diagram of level 1 IoT level 1. So this is the application by using communication APIs. So here REST based communication APIs are WebSocket communication API, communication services. So for that we have some database, for that control service, resource and device. So this is the local to monitoring nodes and perform analysis of stored data. So every level having different components which are discussed in the first one. Device, communication protocols, REST and WebSocket communication protocols, database, control services, resources and last one, devices. So this is the first level of IoT. It has a single node. Device for sensing, monitoring, actuating, storing data, performing analysis and hosting the applications. Next, data involved in not big, so data stored in the local database, not in the cloud database. It is suitable for modeling, design low cost and low complexity solutions. Low cost design, low cost and low complexity solutions. So primary analysis of requirement is not computationally intensive, so can be analyzed locally. So for example for level 1 is home automation. So it is used little bit applications, little bit very small low cost application to develop. So this is about the first IoT level 1. It is having single node. So let's move on to the second level of IoT. It has also single node. but it is sensoring, actuating, perform the remaining process same. Data unit is so big, so data is stored in the cloud. So the difference is, in the first level there is no cloud, but in the level 2 there is a cloud. Same process, application, WebSocket REST or WebSocket communication model from the control service, resource and device in the having database. So it is monitoring node to cloud storage. So this is the difference between cloud level, IoT level 1 and level 2. In the level 1 we don't use any cloud to store the data, but in the level 2 we use some cloud storage. Either whatever, either it is what Amazon Web Service or Oracle, whatever, Reliance Communication, whatever. Here we have some cloud storage. The best example for level 2 is smart irrigation system, that is in the agriculture department. Next, IoT level 3, same, it has a single node for sensing, monitoring, actuating and hosting application. It is okay. It is cloud based application to visualize the data. Primary analysis requirement is computational intensive, so can be aggregated and analyzed in the cloud only. So the best example for level 3 is tracking package handling. The same process, it has single node. It is cloud, same communication protocols, REST, WebSocket communication protocols, database, cloud storage and analysis. But in the level 2 is only storage, the storage element is available. But in the IoT level 3, storage along with analysis. After storing the data, it can be analyzed. It can be analyzed data. Next, level 4. Level 1, 2, 3 having only single node. But from level 4, it having multiple node. It having level 1, this is 1, this is 2. This is only single. It has multiple nodes, devices for sensing, monitoring, actuating, performing analysis and hosting the applications. So if you have 2 nodes, so here 2 control services here. Control service 1, control service 2, resource 1, resource 2, device 1, device 2. The database is same, REST services is same, the analysis component of IoT intelligence. The extra component here, analysis component for IoT intelligence. So we have to analyze the stored data. For that we use here analysis component along with observer node, application and observer node, local and cloud nature. So this is a difference among the IoT level 1, 2, 3 with level 4. Simply you have to remember one thing, IoT level 1, 2, 3 having single node. So the process of transformation of data is also very simple. But in the level 4 we use multiple nodes. So multiple means the complexity of the system also will be increased based on our requirement. So 2 or more nodes are used to send the data. Next, IoT level 5. Same, it has multiple nodes. Data is involved is big. It uses cloud-based application to visualize the data. It is suitable for wireless sensor network. So this is one of the IoT enabling technologies. It is IoT level 5 used best suitable for wireless sensor networks. Primary analysis component is computationally intensive. Component analyze data and stores result in the cloud, make a prediction. The best example for IoT level 5 is forest fire detection. The same process, local and cloud application, observer node, it has multiple nodes. So control service 1, 2, 3, source 1, 2, 3, endpoint device 3. So this is about IoT level 5. The best example for IoT level 5 is forest fire detection. It follows it is used in the wireless sensor network. The last level of IoT is IoT level 6. Same, it has multiple independent nodes. 4, 5 multiple dependent nodes. But in IoT level 6, multiple independent nodes. The best example for IoT level 6 is weather monitoring and structural health monitoring system that is used in the medical department. The diagram for same is same, local. Here we have centralized controller like software defined networking. In the software defined networking also we have centralized network to control all the clients. So here we have application is same, server node is same, analytic components is same as like IoT level 5, REST based or WebSocket communication protocols. So to monitor that, we have centralized controller. For the centralized controller, it connected control service 1, control service 2, like that it can connect it. So in between cloud storage and analysis, monitoring nodes, we have centralized controller also. This is the importance of IoT level 6. So next move on to the conclusion of what is the conclusion among the all the levels. The level 1 has a single node, the same process. IoT level is single node, performs sensing and local analysis. Level 3, it having single node, data is stored, analyzed in the cloud and application is cloud based. Level 4, multiple nodes that performs local analysis. Level 5, multiple nodes, one coordinator node. Next, IoT levels carry multiple nodes, end nodes that perform sensing, send data to the cloud. So this is the conclusion of IoT levels 1, 2, 3, 4, 5, 6. So every level having different specifications, different functions also. In the conclusion base, main important function of level. For example, level 1 is having single node to perform sensing, storage data, perform analysis and host the application. So irrespective of the cloud, without involvement in the cloud. So in the level 2, it performs the sensing and local analysis. It is also without involvement of cloud. But in level 3, it analyzed data is stored in the cloud and analyzed in the cloud by using some also develop some cloud based applications also. Level 4, level 5, level 6, it having multiple nodes having different functions. So next move on to the IoT levels is over. Next, deployment templates. IoT domain specific for IoT. Here we have different applications: home applications, cities, environment, energy systems, retail systems, logistics, industry, agriculture and health and lifestyle. So these are the domain specific IoTs starting from home to health and lifestyle. So in the everything is involvement with the IoT applications. In the home also, the smart cities, smart homes, environment conditions, weather monitoring systems. It can be gather the data, energy systems, retail system, whether it is e-commerce or like that we have. Logistics industry, agriculture, healthcare and lifestyle. So the first one is the home application. Home automation, smart lighting. So in this room we have tube lights. So that tube light can control with the remote. Automatically it can be converted into IoT device. When the tube light is connected to the internet, that can be controlled by a remote. The remote is in our hands. That means we can control the tube light within our remote. That means that is in our hands. That is smart light. So here it helps saving energy by adapting the lighting to the ambient conditions and switching on off dimming the light when needed. When you want, at the time only it can be on. Smart appliances make that management easier and also provide status information to the user remotely. Next, intrusion detection. Any unknown person came to our house, immediately detect the person. Is the person is fraud or real man. For security, cameras also sensor to detect the intrusion and raise alerts. Alerts can be in the form of SMS or mail sent to the user. Next, smoke or gas detectors. The cylinders, it may be the gas leak happened in our home, that can be detected by the IoT devices. So these are the some home appliance or home automation applications. Smart lighting, smart appliances, intrusion detection, security purpose, smoke and gas detectors. Next one, in the cities. The second IoT domain specific, that is cities. Smart parking, smart lighting, smart roads, structural health monitoring, surveillance and energy emergency response. Smart parking, in order to park the four-wheelers. Make the search for parking space easier and convenient for drivers. Smart parking are powered by IoT system that can detect the number of empty parking slots and send the information over the internet to the smart application backends. When you go to any apartment or any shopping mall, big shopping mall like CMR shopping mall, like any big shopping mall, there is no parking space for four-wheelers. So when you use the IoT application there, so it can detect where the slot is empty, where the slot is empty, the information can send to the user immediately. So this is the one of the main important application of IoT, that is smart parking. Next, smart lighting for roads, parks and buildings can help in saving energy. Smart roads equipped with sensors can provide information on driving condition, travel test estimation and alert in case of poor driving conditions, traffic conditions and accidents. Next is structural health monitoring system, that is a network of sensors to monitor the vibration levels in the structures such as bridges and buildings. Very big buildings or big bridges are sometimes it can be monitored by some IoT applications. Next, surveillance. These video feeds from the surveillance cameras can be aggregated in cloud-based scalable storage solutions. The last one, emergency response. IoT systems for fire detection, gas and water leakage detection can help in generating alerts and minimizing their effects on their critical infrastructure. So these are the IoT domain specific of cities: smart parking, smart lighting, smart roads, structural health monitoring, surveillance and emergency response. Next, the third one is environment. In the environment, we have two: weather monitoring and air pollution monitoring. Weather monitoring and air pollution monitoring. So systems collect data from a number of sensors attached and send the data to the cloud-based applications and storage backend. Here you need to remember one thing here: sensor or actuator, whatever the device is available there, it can record the data. After recording, it can send to the destination part. So these are the two things commonly happen in every time: record the data and process the data. Process means it can send to the destination part as per our requirement. In every application, these are the two things, common things: record and processing, along with analyzed. Next, air pollution monitoring. Systems can monitor emission of harmless gases like CO2, CO, NO, NO2, etc. by factories, automobiles using gases and meteorological sensors. The collected data can be analyzed to make informed decision on pollution control approaches. Record, send, analyzed, result. These are the common things for every IoT applications. So in the environment, we have to weather monitoring and air pollution monitoring. Next one, continuation of environment, noise pollution monitoring, forest fire detection, river flood detection. The name itself, noise pollution monitoring. So due to growing urban development, the noise levels in cities have increased and even become alarmingly high in smart cities. It is two fact. In Hyderabad also, Hyderabad, Delhi, Mumbai, Chennai, like that, some metropolitan cities are available. But also noise pollution day by day will increase. IoT based pollution monitoring system, a number of noise monitoring systems that are deployed at different places in a city. Next, forest fire detection. Forest fire detection means if there any fire accident will be occurred or happen, the information can pass to the destination. Natural resources, property and human life, early detection of forest fire can minimize the damage. Next, river flood detection. River floods can cause damage of natural and human resources of human life. Early warnings of floods can be given by monitoring the water level and flow rate. IoT based river flood monitoring system uses a number of sensor nodes and monitor the water level and flow rate of flow rate sensors. Only here two things. One is the water level and flow rate. These two facts can increase. Automatically the data can send to the destination. Oh, water level is increased. Flow rate is very fast. Water level is increasing. Flow rate is very fast. Immediately the data can pass to the destination part. So these are the three: noise pollution monitoring, forest fire detection, and river flood detection. Next, energy. Smart grids, renewable energy systems, and prognostics. What is smart grids? Smart grid is a data communication network integrated with the electrical grids that collect and analyze the data captured in near real time about power transmission, distribution, and consumption. This is about smart grids. Next, renewable energy system. IoT based system integrated with the transformers at the point of interconnection, measure the electrical variables and how much power is fed into the grid. Prognostics. In systems such as power grids, real-time information is collected using specialized electrical sensors are called phasor monitoring units at the substations. So these are the three domains or three applications under energy: smart grids, renewable energy systems, and prognostics. Next, retail, inventory management, smart payments, smart vending machines. What is inventory management? IoT systems are able to enable remote monitoring for inventory using data collected by RFID readers, radio frequency identification cards. Radio frequency identification, when you scan that ID card or any other thing, the data can be visualized. Next is smart payments like PayPal. We have different online platforms to pay the amount, such as contactless payments powered by technologies such as near field communication and Bluetooth. By using Bluetooth also we can do some payments at some times. Next, smart vending machines. Sensors in a smart vending machine monitors its operations and send the data to the cloud, which they can be used for predictive maintenance. So these are the three domains of retail, inventory management, smart payments, and smart vending machines. The last but one, logistics. Route generation and scheduling. It belongs to way of transportation. Fleet tracking, shipment monitoring, and remote vehicle diagnostics. completely it based on the transportation. IoT based backed by cloud can provide first response to the route generation queries, and it can be scaled up to serve a large transportation network. It uses GPS to track locations of vehicle in real time, fleet tracking. So based on this, I did one project also. Shipment monitoring to IoT based shipment monitoring system uses sensors such as temperature, humidity to monitor the conditions of sensor data to cloud where it can be analyzed and detect food spoilage. Next, remote vehicle diagnostic systems can onboard IoT devices for collecting data, vehicle operations, and the status of various vehicle subsystems. So these are the 4 domains: route generation and scheduling, fleet tracking, shipment monitoring, and remote vehicle diagnostics. The last 3: agriculture, industry, and health and lifestyle. In agriculture, smart irrigation systems also developed based on IoT technology to determine the moisture amount in soil, greenhouse control to improve the productivity. In terms of industry, machine diagnostic and prognosis, indoor air quality monitoring system, whether the temperature is high, the humidity, the parameters it can measure. Next, health and lifestyle, health and fitness monitoring, wearable electronics. These are the IoT domain specific: agriculture, industry, health, lifestyle, logistics, retail, energy, environment, and cities and home automation. So these are the IoT levels, 1 to 6 levels, and IoT domain specific, home appliance to health and lifestyle. So this is the session. I'm going to conclude. So these are the references I used for this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.